right. Hello, everyone. Hello. Okay, let's begin. So today, I'm going to talk about while loops, and then I'm going to talk about basically the three string operations that we're going to use in this class mostly. Yep. So, all right. So let's get started. So what's the goal for the day? We'll learn about while loops, use them for input validation, do a little bit of list stuff maybe, and talk about what a Sentinel value is. I guess other examples. We'll talk about constants. So the issue with constants is that I actually do want to talk about, I think I've not actually really talked about how we're going to use them in this class, and so now's a good time to introduce them. Yep, we'll talk about snake case. We'll learn a little bit more about how strings work. Use length, strip, split, and join. We already can use length on strings. I think we've already done that in some previous assignments, but we'll do that more. And next lecture, upper and lower. I think I might have taught upper and lower before, so ignore that part. Okay. Yes, let's pull up a live board, just in case I want to draw something. Okay, sign. All right, good. Okay. Oh Lord, that's a lot of stuff. So, okay, that's all next lecture. So let's talk about the while loop. Can you use join on homework 4? Where do you need join on homework 4? Let me pull up homework 4. Do we have an exam next week? That's a good question. Let's look at the calendar. So, let's see here. Get shareable link, copy link. So here's the course schedule. Let me see. So I guess we have our exam week is next week. That's right. So the exam is going to be, I can talk about the exam a little bit, I guess. I haven't written it yet, but we can talk about what it's going to be. With the merge list, is that what it is that you're talking about? Like, let me pull this down. So, do you mean like in this problem? No. Actually, I don't know. Where would you use join? You don't need it there. I guess you could use it here, sort of, but just use string concatenation. Here you don't need it. I guess you can use join here, but use string concatenation. You could use it here, also use string concatenation, and you won't use it here. I mean, you know what? I guess I'm about to teach it, so you know what? If you really want to use join, then use join, I guess. So it's okay. I was gonna try to forbid it, but then I was like, why am I trying to forbid it? Just, it's fine. It's fine. So let me tell you that I wrote all my solutions without using join because I didn't know if I'd teach it or not. Okay, so what is a while loop? Well, before we talk about while loops, maybe I will talk about the structure of the exam just a little bit. So let's just do 10 seconds on the structure of the exam. And I want to plug this in, take the pen. Okay, so okay, so here's my thinking. Exam one will be basically, it's going to be divided into two parts. One part is going to be multiple choice questions that are going to be on Blackboard. Okay, so I may send out. Didn't you just ask that? Do we get a review? Yeah, maybe next class. Maybe we'll review next class. But yeah, okay. But I'm gonna do some new stuff in the next class too. The reason is there study guide? Not yet. I can send out the study guide from last semester, but I might make some modifications to it based on what we covered and what we haven't covered. So, okay. Exam one is going to be partially multiple choice on Blackboard, and then the other part is going to basically be like a homework. And so it's going to essentially be maybe 5 questions. Maybe 5 questions that are coding. And you'll submit them on GL. So that's generally how the exam's going to work. So it's going to be, I mean, I'm going to feel like multiple choice should probably be like, well, so the 5 questions here, you're going to have all of next week. And they'll be due on Friday. The multiple choice, you can ask the TAs questions, but they're not going to help you like they helped you on the homeworks. So, I was thinking the Blackboard section, we would limit it to maybe 2 hours. But my suspicion, I'm going to design these questions so it should hopefully take you about 20 minutes to maybe 40 minutes. That's the expected time. And I'll probably just establish an upper limit of 2 hours, just so that whenever you start, so make sure whenever you start the question, is homework 5 just part 2 of the exam? No. Homework 5 won't be assigned next week, I guess, and hopefully it's not on the schedule for next week. I think it's, yeah, so you see that homework 5 will be due the week after. So basically, this is like homework 4.5, right? It's going to cover, is the exam open book, open notes? Yes. So open book, open notes. What was the last thing that I wanted to say about the exam? I had something in my head. The only reason why I'm putting a time limit on this is so that you don't get trapped and spend a billion years on it, right? So I hope that no one is going to feel limited. If you have a time extension on if you have a time extension, I can give you time extension on this, but just don't spend your life doing this, okay? Yeah, I actually think it's a decent book. I've looked at it, I've kind of skimmed through it. It's not exactly what this course was based on, but the good thing about the book is that it uses the right coding standards. How many questions on the multiple choice? I haven't written it yet, don't know. But if you have 20 minutes and each multiple choice, 20 to 40 minutes, each multiple choice question will take about 30 seconds to a minute, hopefully. Maybe 5 minutes for a hard one. So my guess is probably maybe 25 questions. But if it's 20 or 30 or 10, well, it's not going to be 10, but if it's like 20-ish, somewhere in this range, right? Like something like that. Yeah, I skimmed through a bunch of different books, and I picked that book because it kind of fits within the course the best. Some books don't use the PEP 8 standard, which is actually the Python standard, which is a big tip that the first. It's a big tip that the author is not like a Python programmer or didn't care enough to like research a little bit about Python before they start writing the book. If they do it in camel case or something, you're like, aha, I've got you. You know. Yeah, I also picked it because it's like around $20. And I'm not a person. I always oppose professors who make students buy expensive books for no real reason. But this is a cheap book that is good, and if you have it, it'll help you. And so I'm thinking it like, you know, camel case is fine. I have nothing problem with camel case. It's just the book is called Python Crash Course by Eric Mathis, I think is his name. Will the exam part look like some of the homework? As I've said, yes. Will it be harder? I'm going to say yes, because here's the thing. Like, if I say no and then it's equal difficulty, everybody's going to say that it was harder. So I mean, pretend, right? Pretend like the questions will be harder than homework. No, I know for a fact that as soon as I say that something is easier, and then, you know, people will all tell me how I was wrong and how it was actually harder and all that stuff. So pretend that the questions will be harder than the homework. My goal is that they will be a roughly equivalent. You know, and so of course when you say roughly equivalent, that's a dangerous bit of vagary. Yeah, so the exam is going to be open. It's going to start Monday, and it's going to be open until Friday. Okay, I might release, if I write the exam over the weekend, I might, you know, I'll talk about, you know what, so I'm going to do more exam review next class, and I'll have some prepared multiple choice questions for you then. So don't worry about it. Just like the homework is put on pause. Yeah, so let's have a lab next week. So lab is still on for next week, okay? So we still have lab. Okay? Okay, so now that I've wasted a huge amount of class time, no homework because you're going to have the exam, right? So, okay, let's get back to actual stuff. That's all I really want to say about the exam right now. I haven't really, honestly, if I'm going to be honest, which normally I am, I haven't even written it yet, so I can't really tell you 100% what it's going to be, but I think I'm going to basically follow the kind of ideas that I did last semester, which was exactly this. We released somewhere between 3, 5, 6 maybe problems that are coding problems, and then we'll have a multiple choice component. I don't try to design the multiple choice component to be tricky or anything, but I would say be as careful as you can be on those, because I think people do get tricked. Okay. All right, so let's get back to work. Okay. So this is not what I want. Okay, so back to while loops, right? So a while loop is a more general type of loop than for, but it can accomplish a few things that while loops cannot, or for loops can't. So, sure, that's true. This is the general syntax for it, right? You use while, while, and then you have some condition, and then a code block. And code block is just something that's tabbed in. Here's some other code that runs. So let me tell you why I teach, well, okay, forget about that. Let's just teach while loops, and then I'll tell you why I teach while loops. So a while loop evaluates the condition, and if the condition is true, it evaluates the tab code that accompanies it, right? If you're one of Dr. Wilson's students and you used a while loop on homework 3, I think that should be okay. But if you're one of my students, I would have said, don't do that, because I hadn't taught it yet. And actually, while loops were kind of the wrong answer for homework 3. I'll explain everything once we get through a little bit of this. So if the condition is true, the loop is executed. If the condition is false, when the condition is evaluated, then the loop doesn't execute anymore. So let me show you. Okay, so here's an example of a while loop. Note that we will continue the loop as long as the string is not quit. So this is kind of one of here's like the first most basic kind of example of, sure, let's just steal this code. Yeah, so my movies is equal to empty list, s is equal to empty string, and while s is not equal to quit, we input a movie and append it into the list, and that's what we do. So let's bring up this, and then let's print out my movies. So, okay, I really don't like how non-spaced out this is. Let's space this code out just a little bit. That looks better. I tend to like to put a space after, for instance, after a bit of tabbed in code. It helps you see, oh yeah, I forgot, I'll make the font size bigger. Ha. So, okay, so let's run while loops. So, let's see, The Matrix. That's a good movie. The Fifth Element. Let's see, Star Wars 4, A New Hope. What's another movie? RoboCop. Ooh, Blade Runner. Some cut. And then Fight Club. Terminator, but Terminator 2. Whoa. Okay, cool. Harry Potter. Harry Potter, but definitely the second one. And Nemo. Okay, so now I'm going to enter quit, right? So what's about to happen, right? When I enter quit, what's about to happen is that S is going to be set to quit, and then when it loops around to the while, it's going to check it, and so S is equal to quit, so it's not equal to quit, so it's going to exit, and then it's going to print out the movies. So there's a few things that this code could do better, right? So let's look and see what happened at the end here. Okay. So why? Okay, so this is what the code did, and it did it well. Normally what I'm going to do is, what if I didn't have this input at the beginning here, and I moved this input statement to here. So let's see how this code differs if I do something like this. So let's enter Holy Grail, Holy Grain, Space Jam. What's a movie I did? Roger Rabbit. Okay, and if I enter done or done quit, what's about to happen here? So you notice here, what happened is that quit got appended to the end of the list, right? And the reason why that happened was because we enter a movie name here and we append it to the list before we check if it's equal to quit, right? So here, S can be equal to quit. So it may get assigned, or I guess appended to the list, right? And so basically the while loop doesn't always check, right? It's not always checking for S equal to quit. It only checks when the loop comes around again, right? So it only checks when this block of code ends and we get to here and it says, okay, well, I want to loop back here. So what is S again? Is it quit? No. Okay, now input a new S. Now if S is quit here, then that's the problem, right? So in order to avoid that, you can always be like, well, if S is not equal to quit, then append it into here. But then you see that what this is doing here is that you have the condition twice. So I don't like this because it's I don't know, it's kind of ugly. And it's checking the condition twice, which is breaking the idea of a while loop, right? Because a while loop, like this will fix it. So if you go, enter movie name A, B, C, quit, so you see that it's not in there, right? But it's really not good because here you're checking the condition and here you're checking the condition. So why are you doing it twice? So that's why it's better if you have, for instance, if you input it at the end here, right? But if we just do it like this, then what's going to happen? If I input, say, a movie, and then the movie is, I guess, I don't know, ABC again, and then I enter quit, we see that quit isn't in the list, which is good. So that's good. Quit isn't in the list. But what is in the list is this initial string here. And we don't want to put some code in here just to prevent that from happening. So how do we prevent that from happening? Right? And what that is that is priming the input. So if you've ever heard of priming the input, what it means is that you take one input before you go into the loop. Well, you can set S to none, but then none would be in the first element of the list. Like you could append, if you set S equals to none, then, and you do something like ABC, then none is going to be the first thing. So here, what happens is if you input the movie name, then what it's going to do is then if it's equal to quit, so if we type in quit first, we're just going to get an empty list, and that's pretty good. And then if we type in something like ABC, and then we type in quit, then we just get our list. So that's why your while loops, if you do while loops with input validation, they should mostly be structured like this. And what I mean like this is that you prime the input first. So you take a first input, and then you check to see if the input is bad, not right. And so basically, or right. So you don't check if S is equal to quit, because that's your quit condition. You want to check if S is not equal to quit, because quit is some kind of thing. Should we normal prime an input when using while loops? So when you're using while loops for input validation, yes. And so, like for instance, let's do another example here. So let's tab that in. And so basically what we're going to do now is can you use break? No. No break. So here's the reason why we don't let break be used. So all the problems we give, well, let me just do input validation on input first, So let me just say that an int is equal to int input, tell me a positive integer. And so remember, a positive integer is something bigger than 0. So let's say while an int is less than or equal to 0, what we're going to do is we're going to reassign it and say that wasn't positive. Tell me a positive integer. So for instance here, let's run this bit of code. Let's put some space so we can kind of ignore that. Yep, okay, so let's run this code and see what happens. Tell me a positive integer, -2. That wasn't positive, tell me another one, -5. That wasn't positive, -17. Okay, 17 this time. Tell me another positive integer, 5. Okay, and that's the quit condition. So basically, in order to do input checking, you see what the kind of format is. First, you prime the input, and then you check for bad input. If it's bad, continue and keep going in the loop. Otherwise, you can exit. And then here you should ask for more input. Okay? So that's a general way that you can start doing some input validation, right? Because the idea here is that, 95% of what a user types in, I'm sure that you've typed stuff into web browsers before, right? The first time you type something in and hit enter, it's garbage, right? And has all kinds of typos and all kinds of problems. So the number one thing that you really always have to think about is what can a user type in, and how can we make sure that if a user types that in, that we catch it. And so currently we don't know how to catch. If they tell you, say a positive integer and they say hello, you're still going to get a value error, right? And that's okay. So we're assuming currently in this class that if I know that you're going to cast something to an integer, then it's completely fine. I don't know. Let's see. Putting the input in the while loop under all the if-elif conditions. Yeah, so generally, if you're going to do something in the loop, the last thing you should do is ask for more user input and then try to go through again. So I think the answer is, yes. Okay. So that's not in Python. See? Not a keyword. Sorry. So it does make it a little bit awkward sometimes. Okay. So that is basically the beginning of a while loop, or at least the idea of while loops. So this is the stuff where, and you can read these slides to go through where I talk about priming the input again. Does the variable change even though it's in the while loop? The answer is it had better change, right? You notice that here, an int goes into the while loop and has a value. If you don't reassign it, then that's a problem. Does it stay the new variable? Yes. So for instance, let's do something where you don't assign it. Let's accidentally leave off this part and see what happens. So let's run the code. Tell me a positive integer, -2. That wasn't positive, tell me an integer, 5. That wasn't wait, what? 7, help me. 13, what? 20, no. 0? -100. 50, well, that was 540. What happened, right? What happened? I'm inputting the thing, but I'm not assigning it to an integer. So what's happened is that I'm now stuck in this loop forever, right? Yeah. So the idea here is that an integer here, if it's not positive and you don't reset it to another value, so you don't do something like this, then it's literally just going to loop forever. So yeah, that is called, so let's just write a comment there. If you don't set an int, this results in an infinite loop. So can you do a while loop for input validation of different types of input? Sure. I mean, yeah, you can do any condition here, right? It can be while a string is not equal to quit, while an int is not negative, while a bunch of different things, right? Yeah. Yeah, absolutely. So what else? What else can you do with while loops? So here's an answer that you can do with while loops. So for instance, here's a math problem. Well, I mean, I kind of already did, right? Because this whole bit of code here is an example of using input validation on strings, right? Basically, you're just validating the input against quit. How do you check for an input type? Oh, so the right answer is try except, but I haven't taught that. Should you use homework while loops on homework 4 part 1? Let me remind myself of what homework 4 part 1 is. Homework 4 part 1. Yes, use a while loop. So the thing about homework 4, so yeah, in homework 4, you have to choose, right? For or while. And one of them is good and one of them is usually not as good. So for instance, if you're going to have a list, right, and you want to go through all the elements in the list, then sometimes usually a for loop is the right answer. So if I have a list is equal to, say, 1, 2, 5, 56, 8, 3, 9, 12, I guess 12, -7, right? And so we say for x in a list, right, print x is a value, right? So let's see, enter a movie name, quit. Tell me a positive integer, 5. And so what you see here is that it's printing out all the values, and it's doing it in kind of an easy way. Let me show you an equivalent while loop. So we have to set index equal to 0. And you're like, what's index? Well, I'll tell you in a second. Index is basically going to keep track of where we are in the list. And so we say while index is less than the length of a list. And then we say print a list at index is a value. So this is almost right. Almost right. But this has a huge bug in it. The huge bug is that at the very end, we need to do an index plus equals 1. Right? If you don't do this, problem, right? So let's see what happens. No movies, quit. Tell me a positive integer, 17. Cool, so here we see that 1 is a value, 2 is a value, 56 is a value, all the way down to -7. Here, 1 is a value, 2 is a value, blah, 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 blah. If we don't do this, a movie's name is quit. 3. Yeah, it didn't like that, did it? Right? So it just keeps going through. And it's going to go like that forever, right? Because here it's printing out the thing at index 0, and it never adds to the index. So it's done. It's stuck, right? So that was an infinite loop. And so you see, why for loops are so much better than while loops in most cases. So now I get to say the moral of the story. We teach for before while for a reason. And that's that, well, there's two reasons. Reason one, for loops iterate more safely, right? When you do for with a list, it's going to iterate through that list, and it's probably not going to result in an infinite loop. No infinite loops. Reason two, for loops are basically 99%, or I'll say 95% of the loops that you write. So when you look at all of your code, for loops are really most of what you do. A while loop is kind of, it's always that 1 in 10, 1 in 20 type exception that you're like, I can't just iterate through a list. I can't, I don't know how many times I'm going to iterate. So why do you ever use a for loop? And here, a while loop. Here's the only reason. I don't know how many times it's going to take to go through. Right? So let's look at these loops and ask ourselves. So for this movie one, right? Do you know how many movies the person's going to enter? Right? And the answer is no. Right? You don't know how many movies. So that's why it's a while loop and not a for loop. Do you know how many times that the person is going to enter a negative number? You don't know how many times a person will enter a negative number. But do you know how many times this thing is going to go through? Yes. It's going to execute len of a list times. Now, I don't always know what len of a list is, but I do know it's going to execute len of a list times, right? So that's fixed. So for loop. Same thing here. You say, oh wait, I know this is going to go, to execute len of a list times. So no, this is bad. Okay. So of course, so this is kind of like the argument here. So for loops iterate more safely. The reason why you ever use a while loop, right? If I ever say, are you going to use a for loop or a while loop? The answer should always be, I'm going to use a for loop because I know I'm iterating through a list. I know how many times I have to go through. It's going to be a range thing, right? For x in range 20, right? Or something like that. Even if it's like, an int equals whatever it is. Remember, it's a positive integer. This is fine too, right? And so if we run this thing, we know that this is going to execute an int number of times. So what's a movie? A movie is, I don't know, Star Wars, quit, positive integer 5, and so Ant-Man, yeah. So you see that this executes 5 times. The index goes from 0 to 4. And so we knew how many times we're going to execute this loop, right? So that's the fundamental difference between like a for loop and a while loop, right? The fundamental difference is if you know how many times it's going to execute, use a for loop. If you don't know how many times you're going to execute it, use a while loop. All right? And that's the fundamental truth between the for loop and the while loop. Okay, let's see what else I have in my lecture notes. Yep, this is the thing where I show you while with lists, infinite loops. So Let's talk about Sentinel values. So what is a Sentinel, right? Other than in the matrix, what's a Sentinel? That's right, it's a watchman, somebody who stands on a tower with a spear, right? So the idea is that a Sentinel value is the value that the while loop is scanning for, and once it finds that value, then it quits, right? So when you have a specific set of values or a value, right, such that you want it to indicate the end of a loop, we call them Sentinel values. Yeah, a Sentinel is kind of like a watchman, also a guard, some kind of mix between the two things. Yep. And then so let's say that we want the loop to go as long as the input is not quit or exit. So how do we do that? So there's two ways to do that, and I'm not going to show it in the slide yet. Let's actually just code it, right? So while, let's say, my string is equal to input, do you want to quit or exit? And so we're going to do while my string is not equal to quit or exit te. And then okay, so end would be a Sentinel value. Sentinel values are usually constants in your program. Let me just show you what I mean by a Sentinel value here. So I've intentionally put a bug in here. Like, what is the bug in this program? So remember, what kind of string evaluates to true and what kind of string evaluates to false? Enter movie name. Movie name is quit. Tell me a positive integer. 5, blah. Do you want to quit or exit? Oh. Hello there. You are my friend. I am going to keep talking. Yeah, so any non-empty string is always true. So what if I actually enter quit here? You entered quit. Okay, exit. Uh-oh. Right? This isn't good. Again, with the infinite loops. What's with this kind of, right? So, yeah, so basically, what we have to do is this. Right? So it might seem duplicative. It might seem, yeah, exactly, you have to distribute the not. So, because, remember what happens, remember the order of operations. What happens is first, algebra. Well, there's no algebra here. So the next thing that happens are comparisons. Well, there's this not equal sign here, right? So that would happen. But that not equal sign doesn't go over this or statement because logic happens last, right? So since logic happens last, you have to do the comparison on both sides of the logic. You have to say, my string is not equal to quit, or my string is not equal to exit. And actually, this should be and. But I just wanted to have another infinite loop, so I set it to work. Okay, a movie name, quit, 5. Whoop, 54, crap. Do you want to quit or exit? No. Continue. Okay, get me out of here. And so now I'm going to type in quit. Boom. Right? So basically what happened here is we typed all these strings and finally quit was equal here, right? So because this was equal, this not equals became false, right? This loop is going to go while my string is not equal to this and also not equal to this. So the point is here that as soon as it's equal to quit or it's equal to exit, right? Either one, then one of these not equals is going to become equal. So it'll become false. and then once anything in an and is false, it'll become false, and then once you get to while false, you pop out of the loop. I don't want to say the word break. And so do you know why we ban break? So let me explain why we ban break for the and also continue. Here's why. We give problems whose solutions don't need them. And also, the other reason is that as soon as we give people break, they immediately stick it in instead of using the while condition. So let me show you, here is some do not use, very bad, no code. So here, let's say while, I guess, well, let's just take this example and redo it. So do you want to quit or exit? And so you say, while my string is not equal to quit, or yeah, sure, okay, or exit. And then you're going to say something like, this is what we always see. If string equals quit, or I guess my, or my string equals exit, and then people will take this condition out, and they'll break. And so you'll see this kind of thing. Quit, tell me pilot 5. Do you want to quit it or exit? Yes, let's exit from the first one. Okay, so do you want to quit or exit, right? And so this is now in here. And so we can basically be like, okay, no, I don't want to quit or exit. You entered no, help, get me out. I don't like this anymore. And then so finally I exit, and then that will do it. But you see what the point is, right? This is a stupid example of using break, but actually the vast majority of what we see when people use break is basically this. And what I mean by basically this is that what people do is, instead of figuring out a good while condition, they just have a bunch of breaks. And so our goal here is to make you figure out while loops without break, so you know when you need it, right? Because you shouldn't be using it when you don't need it, because when another programmer reads your code, they're not going to want to be like, oh, I see, you're going while true, that's weird, and then they have to search, right, for when you actually exit the loop or check to see that you haven't bugged up your code. So it's better if the while condition is a good condition that will actually get you out of the loop instead of using this. So I'm actually going to even delete this. So you'll see it in the lecture, but you won't see it on the GitHub. Okay, cool. Yeah, so here's another way to do it. Here's another way. You can also say while my string is not in quit, exit, like that. So here's another example where it's going to take, it'll take my string and look in this list and compare strings. If it's equal to any of them, then it will exit. So for instance here, enter movie name, quit, 5. Okay, do you want to quit or exit? Nope. Do you want to quit it? No again. Really no. But finally, right, if you enter quit, okay. What's GitBub? I don't know what GitBub is. GitHub is the place where I post all this code, right? Let's see. Hopefully you guys are just trolling me, right? Okay. All right, cool. So, yeah, so what else should we talk about in terms of while loops? So I have an idea. Let's do the discrete log base 3. So what I want to do here is I want to know the power p so that for an integer x, 3 to the power p is less than x. But 3 to the p plus 1 is bigger than x, or maybe equal to. So how about we put the equal sign here? So how do we do this? Well, now you can always take the log, but that's not exactly what we want to do. So what I want to do here is I want to say current is going to be equal to 1, right? And the reason why I'm going to do that is because that is 3 to the power 0. Well, actually, let's just make it current power 0. And then what I'm going to do is say while, let's see, 3 to the current power is less than x, right? And so then what I'm going to do is I'm going to say current power plus equals 1. And so what is this going to do, right? And then after this, we're going to print out the current power. And we'll print out x, and then we'll print out 3 to the current power, and we'll print out 3 to the current power plus 1. Just for the sake of printing literally everything out. Print literally. Okay. So what is this doing, right? What this is doing is it's taking an integer x, and it's going while 3 to this power is less than x. So as soon as 3 to the power is equal to it, then it's going to punch out of here. And all we're doing inside of the while loop is adding 1. So let's see what happens. Enter movie name, quit. Tell me a positive integer, 1. Do you want to quit or exit? I want to quit. Let's enter the thing that I want to tell the log of. Let's say 17. And so let's think about 17 for just a second and game out what happens, right? So 3 to the 0 is equal to 1. So 1 is less than 17, so it'll continue. So then it'll ask, is 3 to the power 1? So 3 less than 17, yes, so it'll continue. And then 3 squared is equal to 9, so 9 is less than 17, so it'll continue. And then when it adds 1 more to the current power, it'll get up to current power equals 3, so 3 cubed is 27. 27 is bigger than 17, so the current power should come out as 3. X should come out as 17 because I haven't changed it. 3 to the current power should come out as 27. 3 to the current power, let's make it current power minus 1, right? So actually we're looking for, so the answer that's going to come out is p plus 1. So let's see what happens. Okay, well I changed it, but I didn't actually rerun the code. So you see that 3, 17, 27, and 81, really this should be 27 and 9, right? Because instead of being current power plus 1, which would be 3 to the power 4, this should be 3 to the power 2. And let's just redo it. 3, quit. And now let's come up with a new thing that we want to take a log of, 61. So 61 is between 27 and 81, right? So because it's between 27 and 81, it'll have a power of 4, current power 4. Yeah. So this is like the rounded up discrete log. Does Python understand e as a number? The answer is, I think if you import math, I think there's math.e. I think that's a constant. Quit 45, quit 2, 3. Yeah, so it has it in there. I mean, but of course, here's the thing: we're not importing this library, so. Does it understand logarithms? Yeah, of course. It can do logs in the math library, but that's not the really. So let me tell you, just the point of this loop is not to teach logs, right? The point is to teach while loops, right? So, yep. Okay. So what else is there to do with while loops? Let's look at my lecture notes again and see what I have. Approximating square roots. This might be a little bit of a complicated example. So, as it turns out, there is a sequence that will, let's say approximate, but it converges to a square root. So, for instance, where is Liveboard? Where is Liveboard? Maybe here? Yes. So this will be, I think, the last example of a while loop that I do, and then I'll talk about join and strip and split again. Maybe constants. So basically you have a sequence a sub n, where a sub n is just a sub 0 is equal to like a starting guess. And a sub n is equal to 1/2 of an minus 1 plus 1 over an minus 1. And as it turns out, if you take the limit of this, well, the limit is n goes to infinity, I should say, of these an's, you're actually going to get the square root of, well, actually, let's put it. So that's what you get. And the thing is that you don't really know how long this loop is going to run. So in order to figure that out, what you do is you actually just kind of run the loop. And let me show you what you do. So let's copy the code. Cool. So I set the error bound to 0.005, and then I take the absolute value of the current minus the previous, and as soon as they're closer than 0.005, we just output the result. Actually, I'll make it 0.0000, whatever. Okay, print. Okay, so let's see what happens when we run this code. Oh, right, and then we input something. So, okay, enter movie name, quit. 5, 3. Nice. Enter the value that we're going to find the square root of. And so what we see is that if I put in, say, 5, it's going to print out every time it goes through the loop. So let's watch what happens when it does this. So what it's going to do is, basically it starts off our current guess at 1, and then the next value after 1 is going to be 3, and then the next guess is 2.3, and then the next guess is 2.38, etc., etc., and then finally we get to 2.2360679, and the actual value is this. And so you see that, we got fairly close. It kind of differs out towards the end, but who cares? you could have run it to more accuracy, right? That's the whole point, is that we could have run it to more accuracy. But you see that this is a while loop, and why, the question is always like, why is this a while loop? The answer is because we didn't know how long it would take to get into the error bound, right? We didn't know how many steps it would take before we got to a stage where the two values were kind of converging. Okay, so let me talk about constants. So yeah, ABS is absolute value. Okay, so a constant value, a constant is a variable, a spot in RAM, where we don't change the value, right? So most programming languages will have like a const keyword or a static or something like that. Like Java has static, C++, C, and other languages have const. Python, you see, we don't actually declare our variables with types, and so we don't use, there's no const keyword in Python. So basically, creating constants in Python is not really, it's not enforced by the programming language, but it's just kind of a something that we do as a tradition. Okay, so what do I mean by that? So in the previous example here, error bound is a constant, right? I set it once at the beginning of the program, pretend that this is the beginning of the program. And I don't change it. Right, so that's the idea of a constant. And so the only difference between a constant and a regular variable is that a constant is in capital snake case rather than lowercase snake case. So how to use constants in this thing? So constants are useful mainly because you can set them once and then you can use them by the constant name rather than by the value. And the reason why you want to do this is generally because it'll allow you to, if you noticed, like I can change the constant value here at the top of the program, and I know for a fact that it's going to change all the instances that I use. Now, of course, I only use it once here, but if this program is a few hundred lines long, it's always possible. Yeah, I know. I'll hide you. So, okay. So then the point is that if you change one value, this is going to change. So if you change this one value here, it changes all the places where the constant was used, which is really the number one kind of advantage of a constant. So is constant no. So if you changed, so if I said like error bound here is equal to 0.2, right, I guess it doesn't like that, but I could, well, that's actually, even that's only a suggestion, so it'll just plow right through it. So for instance, quit, tell me a positive integer, 3, quit, what do we want the log of? I guess 82, find the square root of 17, right? And so you notice here that it'll do it, right? It doesn't care that that it just had to reset the value, right? It just did it. Yeah, so in Python, yes. In other languages, changing a constant does result in a real error, like a syntax error. So yeah, so style note. When you want to indicate a variable as a constant, you use capital snake case like this. So here are some examples of constants that you probably don't really need, but whatever. I guess you did need this one for a homework assignment, but who cares? Cool. Reasons to use constants. Readability, that's always nice. basically, one of the reasons that you want to use constants is because, for instance, if you have something like, say, for instance, new game equals 1, or let's actually say, like, while s not equal to quit, again, and then we'll say print what do you want to do, and let's say that the options are like for, let's say options equals new game, load game, save game, quit. So basically, like, if you wanted to change any of these things, then it would be easier to change if they were constant values, because if you say something like, if, let's say input, choose. So, or I guess really we can just keep this. Then we print like. But what if you wanted to change this to say like start game, right? Now the problem with this is that now you see that this is like broken, right? What you have to do is you have to search through your code for all the instances of new game, and you have to change them to start game. But if you had just declared start game and you had made the option there, and then you had done this, then you see that if you change this to new game, or back to start game, or back to new game again, right? It doesn't matter anymore, because all the instances, you're using the start game constant, even if you change it back to new game, even if you change it back to start game, right? It doesn't matter. So that's really the primary reason for constants. So now let me talk about, in the last few minutes of class, so I'll do the string stuff next time. Maybe I'll talk about, maybe I'll do 2 minutes on join right now. So let's do a minute lecture, like 8A, join, split, strip. So, okay, so first let's talk about how we're going to use constants in the class. And, well, what should I do? Yeah, okay. So, yeah, let's talk about how constants are going to be used in the class. So in general, what you want to do is declare the constants at the top under imports, but over the if name equals main block. Okay, so that's where you want your constants. Never change them. I haven't taught slices yet. Slices are definitely after the first exam, so don't worry about slices. Yeah, so you declare constants at the top, you never change them, and generally, and I think I'm going to be a little bit more lax on this. What we're not going to do, so what we want to avoid is magic values, and by magic values we mean like, by magic values we mean values that are like numbers that are like kind of random. So for instance, if you say like, if someone picks like menu option equals 5, and then you test like if menu option is equal to 5, then you want to then do something, right? And so the point is that if you ever changed the menu option to be, say, 6, or if you changed the 5th thing in the menu or whatever, then all of this will get screwed up. But actually, if you change this to, like, get high scores, right, then, and you define, get high scores is equal to 7 or whatever, then you know that the get high score option is equal to 7. So basically, not all numbers are magic. So 0 and 1 are generally not. If you're testing divisibility, like for instance, if you're testing if things are even or odd, then doing something mod 2 equals 0 or something, variable mod 2 equals 0, that's not magic. But so things that are magic are like menu options, choices from lists, strings, options, like just kind of like random, like strings to type, that kind of thing. So for instance, if someone says like select the start game thing and they type in new game, then that's kind of a magic value that you want to make into a constant. So I'll be more clear as to what magic values are or not. Generally, like things like, it's always nice to have something like days of week is equal to 7, right? Rather than having just everything mod 7. And the reason why is because, not that the days of the week number is ever going to change, right? That's definitely fixed. But the thing is, like, the next programmer who comes upon that code, it requires them, unless your variables are named well, which of course is another requirement of the class, but it increases readability if you say mod days of week, because that will tell them, oh, the variable is some kind of day, right? That's what it tells them. So even if you do like x mod days of week, which is kind of bad in itself, but even if you did something like this, at least it would tell the programmer who comes next, like, oh, x mod days of week, that's x is a day of a week, and so now I know what that variable means. Because otherwise, I promise you, when you're reading someone else's code, or even if you're reading your own code from 2 weeks ago, right, and you look at a variable name, if that variable name is just p or x or t, then you're not going to know what the heck that was, right? All right. So I guess next time I'll talk about split and join and stuff like that. I think I've talked about. So the only thing I want to say right now about split is that if you have a bunch of words here, I guess we can say while s is not equal to quit, print s.split. Okay, so let's enter something. Hey, this is a bunch of words, right? It'll split it into a set of words, and it splits it by white space, so it doesn't care if it's like, hey, this, is it'll still split it just like the other one. And I know that I'm going over, but whatever, I'll talk about join. So let's talk about join for 30 seconds. If you have a list, right? Let's say you start with a list of words. So the list of words is going to be something like robot, Nexus, GitHub, plenary, subaltern. Okay, so let's say that you want to join these words with a next line in between. So join is going to, so join is weird in this language. And what I mean by weird is that it takes you a long time to think about it this way, but you do separator dot join a list of words. So let me show you what this thing does. So the first thing we're going to do is quit. And now what you see is that it joined all of them together into a single string joined by new lines. Now they don't have to be joined by new lines. You can join them, say, by tabs. Can you store the output of join in a variable? Yes. So you can be like, my string equals blah, print my string. Like that. I think there are some languages where basically a list has a join feature, right? And it takes a separator, but not in Python. So Python is separator.join list. Do we need constant formatting for homework 3? No constants for homework 3. I don't care about constants for homework 3. Do you need constants for homework 4? No constants for homework 4. I'm not going to grade on that. The exam, if you, maybe, probably no constants on the exam. Homework 5 and project 1 is where we're going to start enforcing constant rules, okay? So let's quit here. And so now you see that this put tabs in between things. Let's do something different. You can put in multiple characters, right? You can say tab, tab, and then 2 colons. So you can say quit on this first thing. And there you go. So you see that there's a whole, tab, colon, colon, tab, tab, colon, colon, tab, tab, colon. The most standard thing to do is just put a space in between words, but I'm showing you all the different possibilities. And so if you want to use join on homework 4, so split, strip, join are allowed on homework 4. Homework 3 is hard. Yes, unfortunately, this class is hard. And I was thinking about it this way. Is split allowed in homework 3? Yes, there is one homework 3, part 3 needs split. And by needs split, I mean you don't need split, but it's awful without it. Mainly because you have to rewrite split. So, can you use end equals that in homework 4? I would think so, right? Yeah. Homework 3, all for loops. And can you use end equals something in homework 4? I think you want to on the circle problem. It says to use it there. You probably want it on the checkerboard. So yeah, so the answer is yeah, definitely. Yeah, if you're having trouble separating add and remove from the names in homework 3, then use split. That's the whole point, right? So, yeah, I think that's... Any other questions? Any other questions, comments? I guess direct complaints to my email. What's the difference between del and remove? Del removes... Oh, God. So, let's not even talk about del right now. So, because basically del deletes an object from a list, but instead of deleting the object from the list in, like, if you have a list is equal to like 1, 2, 3, 4, 5, and you del a list like 3, or let's del a list 2, then a list 2 is the number 3 here, and it's going to basically del removes by index. And so if we print out a list, we'll see what happens. Yeah, the 2 list methods that we've had, let's see, so you see here that it removed the second element, which is actually 3 here, because this is 0, 1, and 2. So when it deletes this element, it removes it from the list. But the thing is, it's deleting by index and not. How soon is the first project coming? So let's look at the calendar. The calendar says, which is kind of what I'm following this semester, the calendar says that project 1 is going to be assigned the 16th of October. It's going to be due then, the 30th of October. Is there a way to refactor variables with the same name in PyCharm? Yes. You can click on it, and then there should be a refactor button. Here it is. Rename, and then you can rename a list. You can be like blist, and it will do that. Split should not leave extra white space. The only reason why it might leave extra white space is if you're splitting and you're trying to put something into split. Split needs to, like, you need to leave split as s.split with nothing in it. Okay, cool. Split makes a list out of your... Well, if you forget, then just look at lecture 8a right here. Split will take a string and it splits by white space and makes it into a list, right? So if you say add hello, it splits it into add and hello, remove hello, increase automation, Elon Musk, right? Something like that. So that's what split is doing. Okay. And now that I have, you know what? It is the opposite of join. That's right. Is there a way to take only one input where we assigned 2 inputs? Not sure what that means. Homework 3 part 3 has max input. Oh. So the thing is that in homework 3 part 3, so be careful, right? So for instance, like if I'm going to say if the length, so make sure that the length of, if you want to be really careful, you can always say like s is equal to input, and then you can say if the length of s is bigger than or equal to 2, then it, and s.split 0 equals at, and then of course this is terrible code. Really what you should do is you should say split string equals s.split. You take split string 0 is equal to add, print, we got add, right? Something like that. So you don't have to check this, that the len of s is bigger than or equal to 2. We're going to just only give you valid cases. But in the future, you will have to care about that. And you'll have to make sure that the length of the split string is bigger than or equal to 2, because otherwise then you're going to say, like, add the list of names. So we're going to go like name list dot append split string 1. And the problem is that this may not exist, right? In fact, if the length is not bigger than 2, it could be that split string, like if you, split string 0 could also not exist. And the reason why split string 0 could also not exist is mainly because it could be an empty string, right? So if I run this and I just hit enter, you notice that this is an empty list. So you can't access split string 0, you can't access split string 1. So it's always good to put these checks in, because if you put the checks in, then at least you know that your code's not going to crash. Because if you don't put the check in, then what could end up happening, like for instance, let's comment this check out, and then put in quit, and then blah, and then here I think we're inputting, so let's input a bunch of stuff. So, oh wait, no, we want to input nothing. Why didn't it crash? Huh. Interesting. Oh wait, did I not rerun the code? There we go. Okay, I was like, why didn't it crash? Yeah, so the thing is here that if you just hit enter, and you split and enter, and then you check and see if the first thing is add, you're going to get an index error. So that's generally why, you know. All right. Any other questions? Anything else that I can take care of while I'm sitting here? Because I'm probably going to mostly ignore you guys today, because my 341 students have a project that's due tomorrow, and so I'm going to try to get as much help in as possible for them. I will answer questions. I'll be around on the Discord, but I'm not going to be. I'm going to be focusing on 341 today because those poor people, you know. So if you need help, go to office hours, hang out on the Discord, that kind of thing. All right, everyone. Thanks for joining in. Hopefully everyone enjoyed this little bit of thing. I know I kind of... 341 is data structures. So they have a linked list project that they're doing. Okay, what am I doing? Ah, right, outro. That means OBS. OBS, outro. Peace out.